we would like to pass to what would have been maybe in another year our third keynote. This year, as I mentioned during my opening, we are playing a home game, and this is special for us. It's special because this was the first time that we could really expand and feel that there is a place where we can grow as the SPI, where we can receive guests from abroad, from here, where we can actually be useful to the community, maybe also physically, if I can say so, and where we can have this identity. And this is to a large degree, thanks to the fact that we have been able to be part of this great building. It was originally an EPFL idea that the SPI would come here as part of EPFL. The history went differently, but we still came here, and we're very, very happy about this, and to come to call Sion our home. This building is about 10,000 square meter large. Vincent said something about this before. And you will get to see some labs, meet the professors afterwards. But we would like to give you a chance to understand why there is this vision in this canton and in this city now to develop the polar, the environment, the university component. It is really a great honor, and I would like to extend a very warm thank you to Christophe Darbelet, the government president, State Council President of the Canton of Valais, for coming all the way. I know you have a very complicated schedule and logistics today. We were discussing polar logistics. I know navigating the valleys of the Valais is also challenging, so thank you. We really appreciate that you are here. We also appreciate, and I would like to seize this opportunity to say thank you for the work that you do, that your team does. It's fantastic and easy to work with you. We really appreciate it. And we are able, thanks to that, also to put this facility to the use of others from all over Switzerland. So we hope we help you rayonate a little bit beyond the valley as well. And now it is my pleasure to give you the floor to give an introduction to your vision, to the vision of the Canton of Valais, about why we should be here and why we should work here. Thank you.
Dear Daniel, dear scientists, dear guests, ladies and gentlemen, it's a very great honor to stand here in front of you to welcome you in Sion, and a very warm and special welcome to Mr. Frederick Paulsen, member of the board and advisory board of the SPI, and also to its director, Hubertus Fischer. 11 years ago, it was the great idea of the EPFL to involve more the Western Switzerland, the French-speaking part of Switzerland, in the innovation process. And the Canton Valais was also looking for the development of its universities. We were at the very beginning, and we had the idea to create new jobs and with high added value here in Sion. And it was the meeting of the EPFL and the Canton Valais, and Avant-Garde project was born. This project was to bring together on the same site stakeholders, innovation, value change, fundamental research with the EPFL, applied sciences with the HESSO, scientific incubation with the ZIARC Foundation, our foundation of the Canton Valais for innovation, and finally marketing industrialization with the Swiss Innovation Park. At the end of 2022, we had the great pleasure that the Swiss Polar Institute joined this Energy Policy campus. It was the place where we were printing during years the regional newspaper, the Nouvelliste, in this building, and we had to buy and to transform this building for this Alpole building, investing for the canton 65 million Swiss francs. We want to develop solutions for tomorrow, because we are not just a canton with the best vineyards and slopes for skiing. We have one first industry sectors in the canton, and we would like to attract value-added jobs also in the future. In the Valais, the temperature are rising twice as fast as average temperature worldwide. We are very concerned by climate change. And they may have great consequences on our economy because snow is our major attraction in the winter. Our glaciers are the main source of energy, and wine and apricots are our first beverages. Valais alone cannot stop this global dynamic. But thanks to the talents we are attracting here, it can be a locomotive. A locomotive we try to be with you. We want to be pioneers in these fields at the Swiss and global level. The canton of Valais was one of the first cantons in Switzerland to submit a cantonal climate law for consultation. The canton wants to be exemplary in decarbonization and energy optimization, bringing together competencies in renewable energies, carbon capture, storage, and system integration, allow to reduce our impact on our environment. The value chain formed by the energy policy ecosystem propose an integrated solution for our economy and population to be more sustainable for our future. When I look at the surrounding mountains, I feel like Sion and Valais provide a perfect playground for searchers in alpine and polar environments. But it's not just a question of geography. Also, local stakeholders are also willing to support research. And we are now pleased to host the Swiss Polar Institute. The Swiss Polar Institute is well integrated locally. It's already collaborating with the Groupe d'Intervention Médicale en Montagne, our flying doctors, with Air Zermatt and Air Glacier, two helicopter companies what are pioneers for mountain rescue, well known worldwide, and they are organizing together health and safety courses. The Institute also opening new collaboration, including a project on risk management in Valais and Greenland. We are also looking forward for future events here, such as the Climate Festival for Children and Families in December. We hope to see new and exciting collaborations. On behalf of the Canton Valais, thank you to be here. Thank you to search here, to search for better solutions for climate change, to help us to adapt and to cope with these great challenges. Thank you to be here. I wish you a very challenging and interesting day.
Thank you very much. And now I hope you understand why we also enjoy being here. We feel relevant and we have a great connection to the community. And we feel also, and that's thanks to EPFL, that we are provided with fantastic connections to the academic community that we serve. And with this transition, I would like to welcome Matthias Grönmann as a representative of EPFL here to say a few words about the vision of EPFL for those same topics and why does EPFL have Alpole.
Dear President of the State Council, dear Delegate of the State Council, dear President of the Scientific Board of SPI, dear Director of the SPI, dear Chairman of Behring, a strong supporter of the Swiss Polar Institute, dear community and enthusiasts about polar research. On behalf of EPFL, it is my pleasure to address a few words to you. EPFL, with no big surprise, is extremely focused on education, innovation, and on research. And we have the pleasure to have several facilities which are in the associated campuses. We have an associated campus in Neuchâtel with a focus on microengineering. We have an associated campus in Fribourg with building technologies and sustainable architecture. We have an associate campus in Geneva, focusing on bio and neuroengineering. And according to the time plan that is given by the train table, the furthest away is the one in Sion. It's certainly the closest to our heart is the main campus that we have in Sion, where we're focusing on several topics related to areas such as chemistry, green chemistry, polar research, brain. So this is a very successful partnership that we have established many years ago. Actually, we had the first phase that was signed in 2012, and then the second phase that was signed in 2017. And we are currently brainstorming about the third phase. And in the meantime, this partnership has led to the establishment of 16 laboratories at EPFL, in Sion, and in total, 400 collaborators that are located in this city. Among the research topics that we have is in environmental sciences, it is in industrial chemistry, it is in green chemistry, it is in energy, and it is also in brain research. And of course, of special interest to the polar research is the work that is being realized by our teams in environmental engineering. So we have competencies ranging from hydrology with the laboratories of Tom Batin, Janina Alsuler, of Sarah Bonetti, Michael Lening. We have research in soil with the laboratories of Barrett Epley. We have research in extreme environments with the research groups led by Jérôme Chaplin, Julia Schmale, and we have David Touya that is combining in a very interesting way artificial intelligence to research the environment and the impact on the environment. Climate change and solutions, or climate, is a part of the core strategies that we are developing at EPFL that include further fundamental sciences. It includes also intelligent systems, imaging, neurosciences and engineering, health sciences and engineering. And this topic is not only core to the research that we do at EPFL, but it is also a very firm commitment of EPFL that has released earlier this year the climate sustainability strategy, where research is part of it, but it's also how sustainability flows into education, how it flows into innovation, and how it flows into how we're operating our campuses. As a pledge to this commitment, I would like to give two examples of an initiative that we have launched recently, which is called Solutions for Sustainability, where actually we did call the researchers at EPFL to join forces to foster interdisciplinary research, such as to help translating relevant research that is being done in the labs into demonstrators that will help contribute to the reduction of CO2 emission, to the reduction of energy consumption, and contribute to the mitigating the impact on climate. In total, there were 7 projects, 5 smaller ones and 2 larger ones that were selected. And here I'm presenting the 2 larger ones. On the right-hand side, it's the project of coordinated by Mario Paolone, with the ambition to develop new technologies that will help reduce the impact of data centers on the environment. And here, the purpose is essentially to find new ways to have energy efficient data centers by optimizing the way energy is being consumed, by optimizing the way waste energy is being recycled, and reducing the environmental impact of something that is growing in importance in our society, which is more and more data-driven. The second project, which is on the left side, is the project that is being coordinated by Kumar Agraval, who is based in Sion, and together with colleagues in Sion and on the main campus in Lausanne, has proposed to develop a demonstrator which is capturing CO2, utilizing renewable energy to transform the CO2 into useful chemicals. So this is a very relevant contribution to the circular economy, and circular economy of CO2. These initiatives, which were led by EPFL, got some traction at the higher level, and we have recently formed what is called a coalition for green energy and storage, which is combining EPFL, ETH Zurich, and institutes such as the Paul Scherrer, but also the EMPA and others in Switzerland. And we are committed to work across the institutions to help technology being transferred to society to the benefit of the environment. With these few words, I would like to thank Pursue all the researchers for the relevant research that you do in the area of polar research and how to mitigate the impact also on the environment. I would like to thank the state of Valais for hosting EPFL and providing incredible infrastructure to our researchers. And I wish you a very nice rest of the day. Thank you.
Dear all, it's really a pleasure to be all together in this room, and I think it's kind of a launching pad for this Alpole building. I think it's the very first time we have such a gathering around science, and I'm very happy to see that it's about polar and high altitude science. Just a few words about Alpole, introduction of the visit, which will come. You know that within Alpole, we have the Swiss Polar Institute, and it's a great honor for us and great pleasure to exchange with this federal structure. But we have labs as well. And Alpole was actually thought about, as it was said 11 years ago by EPFL, and this connection with the canton of Valais-Wallis made it happen. And we have this big responsibility of producing new science, helpful science on environmental concerns, especially about polar and high altitude regions. And I will tell you how we do that. First of all, it's important to mention that Alpole is not an entity fully separated from EPFL. We are a center, but we are a center attached to a faculty, which is a School of Architecture, Civil and Environmental Engineering, ENAC, one of the faculties of EPFL. And second, within ENAC, we are part of the Institute of Environmental Engineering, IIE. And I want to stress that because you will find a lot of scientists here working on polar and high altitude, I would say, challenges. But we have people on the campus of Lausanne as well doing so, and we are very much attached to them in our policy. Okay, so let's see how this works. Yes. At the moment, within Alpole, you will find 8 research units. They are symbolized here by the picture of the heads of units, but you can imagine that behind these heads, there are tens of bright scientists being PhDs, masters, postdocs, and administrative people, technicians, engineers, and so on. And so it's really a great flavor. You will have a chance to meet some of them. They are in the room. I think we have Meret, who is here. I think we have Tom Batin here. We have Julia Schmaler as well. Julia has the responsibility with me of putting some momentum within Alpole. We've been asked by ENAC and IIE to make that these 8 research units are not just, silos, but build new science together. And that we network as well with the canton. It's very important that we bring useful feedbacks to the canton. Don't forget that, as it was said, 65 million Swiss francs were put for us to exist. So I take that out from a presentation by Claudia Binder, our dean of ENAC. What is the mission actually of Alpole? So that's written here. We need to understand, predict environmental changes in high altitude and high latitude regions. We all know that there are ongoing unprecedented transformations, and we are largely contributing to this, I would say, curiosity-driven science to understand the processes at work. But we do not forget exactly the aspect of mitigation and adaptation. And part of our activity is turned toward how we can help societies to better address these problems and bring solutions. So you have here a few sketches showing you, I would say, keywords of what is done within the Alpole walls. So that covers quite a large range of domains. although we would find, for instance, hydrology as a common keyword. Catchment hydrology is one of them. It's a new lab built by Sarah Bonetti. Snow processes and their relationship with renewable energy. This is Mickey Learning lab, and Hendrik Uwald will speak just a few minutes after about this lab as well. Machine learning and mapping, that's the lab of Davis Tuya. And it's important to understand that this lab, for instance, does not work only on polar and high altitude context. For instance, Davis works a lot on using machine learning on processes, for instance, on the corals in the Red Sea. So you see, it brings us on very different environments. Soil biogeochemistry, that's the lab of Meret Epley, which covers the aspect of soils from the physics, chemistry, and biology components. So very multidisciplinary. In connection with that, in a way, we have the lab of Janina Altschuler on the cryosphere microbiome. So how in the cryospheric environment, microbes, viruses adapt or do not adapt or are transformed. We have the lab of Tom Batin, river, on the Alpine river physical chemistry. So it's again very interdisciplinary on the processes from the glaciers to the end of the river in the sea. And you will have a chance to see the lab as well that will be presented. The lab of Julia Schmaler on atmospheric aerosol processes, working on mountains and high altitude as well. You will have a chance to do with that. And to finish my lab, sense, which is about developing new senses to work on the biogeochemistry of greenhouse gases. And that's what I will present in the next 2 slides. Just 2 slides. So I have the pleasure to handle this quite new lab. It was started 10 months ago. It's a lab which is supported by Frederick Paulsen. I want to thank him very much. He's here. It's a differing pharmaceutical Margareta Kamprad share, which comes together with the share Ingvar Kamprad that supports Julia Schmaler here. So thank you very much, Frederick, for your involvement to support science, especially in polar regions. In a few words, what is the objective of a science lab? We want to work on the biogeochemistry of greenhouse gases. We may have the feeling from outside that is very well understood, but we still have big caveats on the natural feedbacks, especially that this biogeochemistry could bring on future climate changes. And the specificity of the Sense Lab is to approach this problem on a technological background. So how we can develop better sensors to measure greenhouse gases in extreme environment, especially in marine environment, aquatic environment in general. So it's about developing new technologies, and we understand that EPFL is a very good place for that. And especially we work on the laser spectrometry to do in situ measurements. And for instance, 2 weeks ago, together with Sébastien Lavanchi, who is in the room, I was in Greenland together with Samuel Jacquard to do measurements of dissolved methane in fjords and see if the fjords in Greenland are significant sources of this greenhouse gas in the atmosphere. I think that's all for now, and I would give the floor again to Jelena to handle the next lab. And I hope you will enjoy the visit in the next few minutes before lunch. Thank you.
Dear colleagues, dear visitors, it's my pleasure to present you the Cryospheric Science Laboratory in a nutshell, in a couple of sentences. This on behalf of Professor Michi Lenning and on behalf of all my other colleagues working in the lab. We see here one slide, basically no text, only images as illustration. The first point I want to mention here is that the Cryos Lab has also a special status because we are collaborating closely with the WSL SLF Institute for Snow and Avalanche Research. So here we also have a link with the Federal Research Institutes. And our research, probably known to some of you, is mainly in the area of classical cryosphere, mainly focused on snow and ice, this in the Alpine region as well in polar regions. Some images are illustrating that we are active in taking measurements, in data analysis, and in numerical simulation. So this is, let's say, our core business, and we have several projects have been involved in large-scale campaigns like the Mosaic expedition, We're based in Antarctica since a couple of years. We have installations in the mountains, where we look particularly at processes like snow energy and mass balance, the interaction with the atmosphere, snow as a water resource, and a link to surface hydrology and also to renewable energy. This is probably a little bit a surprise, but it's our second track. Since a couple of years, the laboratory is very much engaged in combining the classical snow and ice research in combination with the renewable energy, in particular in mountain areas. That is photovoltaic, as illustrated here, the potential of wind power as well, and assessing also natural hazards and risks related to cryospheric processes. So a lot of different domains where we're active, and you've seen also here in the slide that it goes from these sometimes logistically very challenging installations to the development of state-of-the-art and really sophisticated numerical models that can handle processes like snow transport, sublimation in a numerical way. We're also offering a lab visit later on, so you're welcome to join us in the lab, and we're very happy to give you more explanations. Thank you very much.
Welcome also on my behalf to Sion at the EPFL Valais Wallis campus. There's also a German-speaking part to that. Actually, some of the chairs here speak German as well, which we believe is quite good for the integration in the canton. So I'm heading the Extreme Environments Research Lab. We're also a sponsor chair, the Ingvar Kamprad chair by Ferring Pharmaceuticals. And a small fact on the side, we've actually been the first lab on the ground here in Sion. And so we had the opportunity since 2019 to become real fans of Sion and the Valais. What do we do? So we're committed to fundamental research, to create integrated understanding of climate relevant processes in extreme environments. And with extreme environments, we mean polar and alpine regions, so including Valais as well. And we're mostly atmospheric scientists, so we have a certain perspective on things. That means we're interested in the composition of the atmosphere, in particular aerosols and how they interact with the cryosphere, the ocean, land, and human activities, which also means we can very nicely connect to the other labs here within Alpole. And all of that is with the perspective of what is climate relevant. So I've brought a little sketch. No worries, we won't go through that. It's not a lecture, but it just gives you an idea of that. There is many small scale processes from the mountains in the mid latitudes to the high latitudes, the North Pole and Antarctica, that we're interested in. And so we do have specific research questions that have to do with what are anthropogenic sources of aerosols, what are natural sources, how do these natural sources actually change with climate change? Think of retreating sea ice, retreating glaciers, all the dust, the sea spray that comes with it. And what does that actually mean for the radiative transfer in the atmosphere? Because these particles interact with clouds and with solar radiation directly. So there's lots of things happening. And I've brought just one picture that shows how we do our science in the field. It's from the recent Art of Melt expedition on the icebreaker Uden. I'm going to say it's my favorite icebreaker, not because of certain people in the room, but actually coming back to the talk of Jan this morning, when you leave the ship, or actually when you're on the ship, you have a sense of fun and fantastic support. It's really the best crew we've ever worked with, and they make it possible for us to fly the helikite that you see, which is not trivial to do from a ship. We fly because of meteorological situations, boundary layer inversions, so we can't just measure at the ship itself. We need to go further up in the atmosphere to understand how clouds are formed. We don't always do that. We also have this red container, which you might have seen outside, which we've also deployed on several icebreakers. And with that, already finished, I'd like to say there is a fantastic team behind all of this. You'll see many of us here in the room. If you have questions, just reach out to us. We're very happy to answer those. Thanks a lot.
Thank you so much. Welcome everyone, and dear colleagues, dear friends. I brought some melting ice
with me, so not to lose context. With this melting ice, I want to kind of make the emphasis that at the River Lab, we really work at the interface between the ice that is melting and the streams that are forming downstream from the melting ice on the one hand. On the other hand, I want to make a strong point. So many of us in here work on ice only, or like on derivatives of like ice and snow, etc., in the sense of the physics and the hydrology there. Whenever you go to a glacier, there's more than ice. There are thousands and thousands of different microorganisms within that ice. And today we understand glaciers as a microbiome on its own, with its own microbiome. And that's exactly the subject of our research. So we do work on shrinking glaciers in the mountains, and we're very much interested in how this shrinkage affects the downstream microbiome and some of the important ecosystem functions that this microbiome fulfills. So one of our emphasis is on the so-called microbial biofilms here. We are very much involved in biogeochemistry, mostly the global carbon cycle. Despite the fact that these streams, they look like without being devoid of life, there's a lot of life in there. And that life indeed drives some of the greenhouse gases that also Jérôme mentioned. And the greenhouse gases, some of them are important for the carbon cycle and all of them for the climate. So what we like to do in the River Lab, we like to conduct very complicated and large expeditions that take us all around the world. So I'm always telling people, so we do cruises as well, but we do cruise the roof of our the roof of our planet, right? Which is even more complicated than being on an icebreaker. We also like to do large-scale experiments where we heat over like the time of like 3 months the water of the stream in the mountains to kind of simulate climate warming. When I saw the electricity bill, I thought, okay, we stop with this. We do lots of bench scale experiments in the lab, and I'm more than happy if you're interested to take you through the lab. Plus, since we work on very complex systems, including like microorganisms, we do lots of bioinformatics and data science-driven research in the lab as well as modeling. Thank you very much. So with this, I brought you really like from the ice, right, to the downstream ecosystems. And with this, hopefully, you will take us to lunch. Thank you so much.